Hello everyone, welcome to Abdemi. I am Dr. Nandita and today in this video I am going to do some mathematical problems based on the concept that you have learned in the chapter Electrochemistry. So let's get started. This problem came in JEE Advanced Examination 2022 and the problem is consider the strong electrolyte ZmXn, UMYP and VMXn. So, three strong electrolytes are given. Limiting molar conductivity lambda 0 of UMYP and VMXn are given as 250 and 440 centimeter square per mole respectively. We have to calculate the value of M plus N plus P in this problem. Some informations are given here. Lambda 0, which is represented in the unit as Siemens centimeter square per mole, and for some ions these are given, the values are given, okay, where the lambda 0 is the limiting molar conductivity of ions, and also the plot of molar conductivity of ZmXn versus root C is given below. So for the second and third electrolytes, all the three are strong electrolytes, but for second and third electrolytes, the limiting molar conductivity values, that is lambda 0, are given, and for the first electrolyte ZmXn, the plot of ZmXn versus lambda ZmXn versus C to the power half is given. So let's see with the given information how can we solve the problem, right? So let's first start with the first electrolyte. All of them are strong electrolytes. So we will start with the ZmXn first. So because the plot is given for the first electrolyte, so what can we write? We can write that lambda, because it is a straight line you can see, so we can write that lambda m C is equal to lambda m0 minus kappa root C. And from this equation, what can we say? That it is having the slope of minus k, and the intercept, because it is a straight line you can see from the plot, so the intercept of on y-axis, from the relationship you can say that it is lambda m0, right? And this minus k can be written as equal to delta y by delta x. Now from the plot you can see that delta y is nothing but 339 minus 336 divided by delta x is corresponding root C values for 339 and 336. So root C value for 339 is 0.01 and root C value for 336 is 0.04. Now if you solve, you will get as, because this is nothing but minus 100, right? Now if you solve, you will get it. So from here k is coming out as 100 or kappa. Kappa is coming out as 100. Now for the strong electrolyte, what else we can write? We can write ZmXn can be written as, before that let's do one more thing. So let's make a box here, I will use it later. So from this equation, if I number it as A or name it as A, we can write lambda MC is equal to lambda M0 minus kappa root C. So lambda M0 from this equation will come out as lambda MC plus kappa root C. Lambda MC, from here you can use this value of 339 plus your kappa has come out as 100. That is our slope. We solved it. Slope was minus k and it was minus 100. So k or kappa has come out as 100. So times the root C from here you can use 0.01. This is the corresponding root C value for the lambda MC, that is 339. And if you solve, we will get 340. And this is lambda M0 ZMXN. So this is equal to 340, right? So lambda M0 values for the other two electrolytes are given, and for the first electrolytes we have calculated it as 340 from the given plot of lambda of ZMXN versus root C, right? So now for ZMXN, what can we write? We can write, it is nothing but M lambda 0 Z to the power n plus n lambda 0 x to the power m minus. This can be written like this. And from here, our lambda 0 ZMXN, we have calculated it as 340, and m times lambda 0 Zn plus, you can get it from here, this is m times 50 plus n times lambda 0 xm minus, you can get it here, this is 80, and so you will get 340 is equal to 50n plus 80, 50m plus 80n. Now this is our, so this is for the first electrolyte ZMXN. So now if you just remember, I will write down in the next one. So 50m plus 80n, let's move on to the next one, next slide. 50m plus 80n, I have to write it down here again. So 50, I'm sorry, let's choose this color, 50m plus 80n is equal to 340, which we have calculated for the first electrolyte ZMXN. Now from the previous slide, I have again actually used, I will use this table for the values, that's why I have kept the table in this slide as well. So let's do for the same for the other two electrolytes. So now we'll do for UMYP. We'll do in the similar manner. So M lambda 0 UP plus P lambda 0 Y M minus. For the second electrolyte, we can write in the similar manner. Let's again put the values. UMYP has been given as 250, right? And M is kept here as such, and lambda 0 UP plus is 25 plus P times lambda 0 ym minus, from this table you can use 100. So from here you will get 250 is equal to 25 m plus 100 p. Let's just name the equation as equation 1. Again, similarly, maybe in this side, I will do for the other electrolyte, that is the third one, that is VMXN. This can be written as M lambda 0 V n plus n lambda 0 V, n lambda 0 x m minus, right? VMXN is given as 440 and m times lambda 0 Vn plus is 100 plus n times lambda 0 xm minus is 80. So we will get 440 is equal to 100 m plus 80 n, right? Now let's name the equation as equation 2. And firstly, what we got in the beginning for the first electrolyte, we will name this equation as equation 3. Now if you subtract equation 3 from equation 2, what you will get is that 440 minus 340 is giving you 100 m. We are subtracting equation 3 from equation 2. So that's the numbers we are getting from the subtraction, right? So what we are getting, 100 m minus 50 m plus this 80 n minus 80 n will get cancelled out, so we are not writing it. So it is 0. So 50 m is equal to then 100. So m has come out as 2. Now our m value has been calculated as 2. From equation 1, then from 1, if you put the value of m, then you will get the value of p. So 250 is equal to 25 times 2 plus 100p. So 100p is giving you 200. So p is again 2 here, right? So our m is equal to 2 and p is equal to 2. Now again, if you use the equation 2 here, so from equation 2, if you put the value of m, you will get the value of n. So 440 is giving you 100 times 2, because we have calculated the m as 2, plus 80n. This is giving you 440 is equal to 200 plus 80n. So 0, 4, 2 is equal to 80n. So n has come out as 3. So now that we have the values of m, n and p, we can easily calculate the value of m plus n plus p. So m plus n plus p is equal to 2 plus 3 plus 2 is equal to 7. So this is what they have asked to calculate. I hope you have understood. So if you put the values here, so we have to write it down 7. So m plus n plus p is equal to 7. I hope you have understood. Now let's move on to the next one. And this problem appeared in JEE main exam 2021. This is asking 5.0 mole per dm cube or cubic decimeter aqueous solution of KCl has a conductance of 0.55 millisiemens when measured in a cell constant 1.3 centimeter inverse. The molar conductivity of this solution we have to calculate in the unit millisiemens meter square per mole, and round up to the nearest integer we have to calculate the molar conductivity of this given solution, KCl solution. Now, what are the information that are given is that the concentration. So, concentration is given as 5.0 mole per cubic decimeter, which is equivalent to mole per liter as well. So we can directly use the concentration value as 5 mole per liter. Conductance is given. This is our molarity. Conductance is given as 0.55 millisiemens. Also the cell constant value is also given. So cell constant is nothing but GL by A, right? And this is equal to 1.3 centimeter inverse, or you can write in terms of meter as 1.3 times 100, right? So now molar conductivity and conductivity are related with each other with the following relationship. So lambda m, that is the molar conductivity, is equal to kappa divided by C. This is our molar conductivity, lambda m, and this is our conductivity. So now if you put the value, you will get so your conductance is given here. Also this is the value of the cell constant only. So now I'm sorry, this is not cell constant, this is our kappa. Kappa is related, that is conductivity is related to the conductance and the cell constant by the following relation, where you can use the value of the cell constant which is already given, and also the value of the conductance is also given. So from here you can easily calculate the kappa as your conductance has been given as 0.55 millisiemens, right, times your cell constant, that is 1.3 times 100 your meter inverse, because we have already converted into meter inverse from centimeter inverse. So this is giving you 55 millisiemens times 1.3 meter inverse, right? Now if you put the value of kappa from here into this equation where the molar conductivity and conductivity are related, you will get 55 millisiemens times 1.3 meter inverse divided by your concentration, that is in molarity we have it as 5.0 mole per liter, and if you now check for the unit, liter can go up with the so if you calculate the numbers you will get 14.3. Now I will check the units, right? So you have millisiemens times meter inverse, right, times mole inverse, and in place of liter I will write meter cube, right? So you have the value of 14.3 millisiemens and meter square mole inverse, right? You can check from here. So in the blank, if you consider the nearest integer, so you have 40 millisiemens meter square mole inverse. So in the blank you will just put the number 14, right? Very simple. You just need to check what are the values given and what you need to calculate and how these parameters are related to each other. Only you need to remember the formulas. So here I have used two formulas, that is for conductivity I have used GL by A, and also the molar conductivity is related to the conductivity by the following relation. So with the help of these two known equation, I have solved this problem very easily. So I hope you have enjoyed this video. For more such videos, you need to visit our website, Abdemi website. So get connected with Abdemi. Thank you very much. Have a great day. Thank you.